Section 3.5 is about solving systems of equations that have three variables. When you have three variables, you're talking not about a line, but you're talking about a plane. And when you have three planes that you're graphing, there are three possible ways that those planes could create a solution. The first is those planes could intersect in one spot, and we call that the point x, y, and z. So we add depth as our third axis. They could intersect in a line, which would have infinite solutions, or those three planes could be right on top of each other. They could all be the same plane, and those would have infinite solutions. And then those three planes could touch not at all. They could look like this, or two of them could be parallel and touch the third, but all three of them have to touch, or they could all be parallel to each other and they never touch at all. These are the three possible solutions for a system of equations that has three variables. Now that leads us to a new definition, something called an ordered triple. Instead of an ordered pair, you now have three-dimensional points. You have an x, a y, and a z, and those are called ordered triples. So here we have a system of equations, but these equations have three variables in them. Well, if you're going to solve for three variables, you have to have three equations. Just like when we solved for two variables, we had to have two equations. Same idea. Here's how we're going to do this. We'll start with the first two equations, and I'll use some colors to maybe help you. I'm going to take the first two equations, and I'm going to write them on top of each other. Now I'm going to use elimination to get one of the variables to go away. Well, right now I can't. Elimination won't get rid of anything. So I'm going to take the top equation and multiply it by 2. So that'll give me a new set of equations. Now that I have 2x and 2x, I can subtract those and they will be eliminated. The rest of it becomes minus a negative. 4 minus a negative is 5y. 2 minus 3 is negative 1z. And 20 minus a negative is 25. So I have a new equation that I'm going to hold on to and use that in a little bit. Now I'm going to go back and take the other two equations, the second one and the third one this time, and again write them right on top of each other. In this example, 2x and 2x are already ready to be eliminated with subtraction, so I'll do that. Negative 1 plus 3 is 2. 3 plus 5 is 8 for the z. And then negative 5 minus 27 is negative 32. So now you see that I have two equations. This one, which does not have an x in it. This one that does not have an x in it. So now I'm going to take those two equations and write them. And now I'm going to use elimination again, but right now I won't be able to get rid of any of them. So it looks like the top by 8 will be the easiest way to go. Because these coefficients are the same, I'm going to add them to eliminate the z's. 40 and 2 is 42y, and that's going to equal 168. Divide both sides by 42, and you get y equals 4. So there's part of my solution. Now that I have y equals 4, I want to use one of the equations where there's only a y and something else. So I'm going to plug that y equals 4 into 5y minus z equals 25, and I'm going to solve that for the z. This is a 20, which I can subtract from both sides. Get a little more room here. So negative z equals 5, which means positive z equals negative 5. So there's my second one. I have the y, I have the z. Last step is to find an equation that I can plug y and z into and get an x. Well, how about that original equation at the very top? I have an x plus a 2 times y, which is 4. The z is a negative 5, so plus negative 5, and that equals 10. So that's an 8 minus 5, so this is a plus 3 equals 10, and then we'll subtract 3. So x equals 7. So now I know the x, the y, and the z. I'll write my answer as an ordered triple. 7, 4, negative 5. Here's another system with three variables to solve. I'll take the first two equations and write them out. It doesn't matter which letter you eliminate. I'll just eliminate the x's here. So if I multiply the top by a 3, I'll get a 12. And if I multiply the bottom by negative 2, I'll get a 12. So these are my new equations, and because the coefficients are opposite, I'm going to want to add. 12 minus 12, gone. Negative 18 plus 18, that's gone too. 12 plus negative 12, gone, and so is 36 plus negative 36. We end up with 0 equals 0. Now, if all three of the letters cancel off, we know that those two equations are the same plane. The equations have just been altered slightly to make them look like they're different, but they're actually the same plane, or something like the same sheet of paper. So all we'd have to do now is figure out if those planes, if that plane intersects the third one at all, or not at all. Could this last one be a different line that was parallel, or would it actually touch? So let's take a look. We could use any one of the first two equations because they're the same. I'll just use the second one. Again, it won't matter which variable you eliminate. Let's do the x again. Top by 5 will give me a 30. Bottom by negative 6 will give me a negative 30, and then I could add. So these are my new equations. The coefficients are opposite, so I'll add them. So the x's will be eliminated. Negative 45 and 48 is 3y. 30 plus negative 60 is negative 30z. And 90 plus negative 120 is negative 30. Now, one thing I notice here is these all contain a 3, so I'm just going to divide everything by 3 and simplify. So 10z equals negative 10. So the point is, when I look at that plane that I said was the same, and the third one, they cross using two variables, which means they cross in a line. So it's not the same plane, and it's not parallel. So we must have an infinite number of solutions somewhere. Our next example, three variables again. Take the first two equations and see if you can use elimination. Doesn't matter again which letter you eliminate. Let's do the C this time. I got 8 and 12, so if I multiply 8 times 3, I'll get a negative 24. And if I multiply the negative 12 times 2, I'll get a negative 24. And then I can eliminate the C. So these are my new equations. Coefficients are the same, so subtraction is in order here. 18 minus 18, gone. 36 minus 36, gone. And negative 24 plus 24, gone. So we get a 0. 72 minus 60, however, is a 12. Well, 0 equals 12, that's a false statement. And remember, if that's false, that means these two lines, the two that we've looked at, they don't touch anywhere. And if the first two don't touch, it doesn't even matter if the third one touches, because you're trying to find the place where all three of the planes cross, so we know for sure that this system has no solutions. Our last example is a real-world problem that involves three unknowns, so we're going to make three equations and then solve the system using three variables. Take a minute, read through this, and try to figure out what the three unknowns are. So we're looking to sell seats at a stadium, and I made U the number of seats in the upper area, the M the number of seats in the middle area, and the B the number of seats in the bottom. So those are my three unknowns that I'm trying to find. Now I have to have three equations to do that. Well, in the first sentence, I'm told that there are 49,000 seats in the whole stadium. Well, if I add the upper to the middle to the bottom section, that should give me 4,900 seats. So that's one equation. The next sets of equations talk about tickets and how much they cost. So tickets in the upper level are $25, so I'm going to say $25 per ticket in the upper level. I'm going to add that to $30 per ticket on the middle level, and then I'm going to add that to $35 per ticket on the bottom level. The question is, what is that going to equal? Well, the answer is down here when it says the total revenue is $1,419,500. If I add all those tickets up together, that will tell me how much my total revenue is. So that's going to equal this number. That's the second equation. Last equation comes from right here, the number of the seats in the middle and the bottom levels together equal the number of seats in the upper. So the upper level is going to equal the middle and the bottom added together. Now, this one is kind of interesting because here I have an isolated variable, and typically when we have a variable that's isolated, we can use substitution. And if you wanted to use substitution, you could. You could plug m plus b in for the u, and you could use substitution that way. I'm going to try to stay consistent with what we've been doing. So I'm going to actually subtract m and b. Make this equation u minus m minus b equals 0. And then I'm going to put the top equation underneath it, u plus m plus b equals 49,000. And then I can stay consistent with elimination. And this one's nice because they're already set up for me to use. I can either add and eliminate m and b or subtract and eliminate u's. I'll add. And so I'll get a 2u. The m's are gone. The b's are gone. That's nice. And I'll get 49,000. So then we'll divide both sides by 2. So the upper level seats cost 24,500. So I get this value, u equals 24,500, when I plugged into the first and the third one. So now I've got to combine one of the other two equations, the first one and the second one perhaps. And so I'll try to make you see it. So I'll write the first one over top of the second one. So I'm going to take that first equation, I'm going to multiply everything by 30. And the reason I'm going to multiply by 30 is because then I can get rid of the m. Since I already know the u, it'll be much easier for me to find the b. So the m's have a 30 and a 30, so I'm going to subtract those. Those will be eliminated. 30 minus 25 is 5u. 30 minus 35 is minus 5b. And then when I subtract those numbers, I get 50,500. Now the nice thing I can do now is I know what the u is, so I can plug in 24,500 in for u and then solve for the b. Alright, so I'm going to go back up here. U plus m plus b equals 49,000. That's the last one I'll use. U plus m plus b. I know the u is 24,500. I don't know the m. I know the b is 14,400. And I know the total number is 49,000. So now I can do all this and find out what the m is. Adding like terms that are on the same side. So 38,900 plus m equals 49,000, and then subtract 38,900.